Hi there, Mr. Holcomb here with another episode of the Math Behind the Modules. Alright, this is lesson 17, Divisibility Test for 3 and 9. This is a really neat lesson where it teaches kids how to divide or find factors and realize how if really big numbers can be divided by small numbers. In other words, finding factors of large numbers. So we're going to go through all the tricks of the trade to make our lives easier. So, opening exercise. Below is a list of 10 numbers, right here. So 10 numbers. Place each number in the circle that is a factor of the number. Some numbers can be placed in the circle. For example, if 32 are on the list, we place them in circles with 2, 4, and 8 because they are all factors of 32. So what we're really doing is if I took this 32, I'd say that is 1 times 32, or 2 times 16. Or 4 times 8. Okay, so our factors are 1, 2, 4, 8, 16, and 32. These are all numbers that will go into 32 if we divide. So that's what we're doing. So what is divisible by 2? Well, we learned from the last lesson an even number is divisible by 2. So 0, 2, 4, 6, or 8, any number that ends in those numbers are even. Okay, so I just underline the unit digit or the ones digit. So I underline 24 is even, 36 is even, 80 is even, 214 is even. I should be using semicolons here because it would look like a really big number with just commas. 360 is even, 4,678 is even, and 414,940 is also even. Okay. The next rule we have is divisible by 4s. Okay, so I'm not going to get into it on this page because the students were just trying to figure out what goes where here. So I'm just going to list these. So what we could have done is gone here. Okay, so now I've got my trusty calculator, so I'm going to cheat here at first. So 24 divided by 4, and if I don't get a decimal, it goes there. So this is 24. Okay, 24, next number, 36 divided by 4. Enter, is 9. So since it's an integer, it's divisible by 4. 9 times 4 is 36, so 36 is divisible by 4. I'm not going to do every single one of these like this. I'm just giving you an idea. So if I go to 80, 80 divided by 4 is 20. That's an integer, so 80 is divisible by 4. Okay. So 4 is a factor of 80. Now let's look at 115. So if I take 115 and divide it by 4, I get a decimal, 28.75. So that is not going to go in this circle. Okay? And that's how you would do this on your own. I'm not going to continue that. It would take a really long time. So what I am going to do is just give you the answers to these. They should have already been done in class. Okay, so there, I've done that for you. So if you need to pause the video, check your answers. This is the key to what is divisible by what, or what are factors of what numbers. Okay? So take a look at that, pause it if necessary, and then move on. Okay, so now we're going to have rules for divisibility. So the divisibility rule for 2 states that if it is an even number and you can divide by 2, then the units digit, or the ones, would be 0, 2, 4, 6, or 8. Okay, so rather than watching me write with hand scratch with this pen, I'm just going to bring in typed terms. Okay, so the answer to divisibility rule for 2 is if and only if its unit digit is 0, 2, 4, 6, or 8. Now, I told the students in class we have little shortcuts in math, and they will learn in geometry in a few years, but there's nothing wrong with introducing something earlier. To save time, it's mathematical shorthand, if you will, and it says if and only if. Well, we have a symbol for that. It's just the word if and that additional f. So IFF replaces those 4 words, if and only if. The next one is the divisibility rule for 4. The rule for 4 is if and only if its last 2 digits are a number divisible by 4. So I'm going to just give you an example here. The last 2 digits. So if I have a 3-digit number, 416, if the last 2 digits are divisible by 4, then the whole number is. So 4 will go into 16, so 4 should go into 416. 1 times 4 is 4, and then bring down the 1, 0, and 4 goes into 16 4 times. And there are no leftovers. 4 times 4 is 16, and I subtract it. So it is true. If the last 2 digits are divisible by 4, then I don't care if I put a 137 in front of this. 137,416 divisible by 4. Okay, rule for 5 says that if and only if its unit digit is 0 or 5. Remember, the unit digit is the last number in this, the last digit in the number. So if I had a number such as 315, the last digit is a 5, and it is divisible by 5. So if I check that, 6 times 5 is 30. Subtract, bring down the 1, bring down the 5. 5 goes into 15 3 times. Subtract, and get 0. No remainder. So 5 is a factor of 315. Okay? The divisibility rule for 8 says that if and only if its last 3 digits are a number divisible by 8. Okay? So I'm just going to multiply something. So I'm going to take 15 times 8. 5 times 8 is 40. 8 times 1 is 8, plus 4 is 12. So the number is 120. So I can pick any number, as long as that last 3 is divisible by 8, because 120 divided by 8 is 15, and I can put any amount of numbers in front, so 34,120. Since 120 is divisible by 8, then this whole big number is divisible by 8. Let's check. Okay, 8 times 4 is 32. Subtract, 4 minus 2 is 2, bring down the 1. 8 goes into 21 2 times. 8 times 2 is 16. Subtract, borrow from the 2. 11 minus 6 is 5. Bring down the 2. 8 times 5 is 40. 8 times 6 is 48. 52 minus 48 is 4. Bring down this 20. Or the 0, I'm sorry, bring down the 0. We have 40. And 8 will go into 40 5 times. No remainder. So 5 times 8 is 40. And when I check, I get a remainder of 0. So 8 is a factor of 34,120 simply because 8 is a factor of the last 3 digits. Pretty cool stuff. All right, divisibility rule for 10 says that if and only if its unit digit is 0, the unit digit is 0 is the last digit, the ones digit. So if I have 180, I divide it by 10 because that's a 0. 10 will go into 18 ones. 10 will go into 88 times. And we're done. No remainder. 8 times 10 is 80. And we have no remainder. So 10 is a factor of 180. When you divide, you find the other factor, which is 18. So as long as the units digit, the last number, is 0, then it's divisible by 10. Okay, now decimal numbers with fraction parts do not follow the divisibility test. So we can't do this with fractions or decimals. It's only with integers. Okay, and so now there's the last 2 rules. We're really going to focus on this in this lesson. Divisibility rules for 3 and the divisibility rule for 4. Okay, so here's the divisibility rule for 3. If the sum of the digits is divisible by 3, then the number is divisible by 3. This is really cool. So what is going to happen here is I'm just going to make up a number here. 8, 5, 2, 6, 1. All right, 8 plus 5 is 13, plus 2, so I'm going to put little plus signs. So what we're doing is adding up the digits. 8 plus 5 is 13, plus 2 is 15 plus 6 is 21, plus 1 is 22. Okay, 22 is not divisible by 3, but 24 is. So I'm going to add this 2 at the end. So I just made up a number, 852,612. And I'm going to divide it by 3. So when I added all of these up, I got 24. 8 plus 5 is 13, 15, 21, 22, 23, 24. If I divide the sum of its digits and I get an integer, then this whole number is divisible by 3. So if I ask myself 8 divided by 3, 3 times 2 is 6. Subtract, I get a 2. Bring down my 5. 8 times 3 is 24. Subtract, bring down 2. 3 goes into 12 4 times evenly. 4 times 3 is 12. Subtract, get 0. Bring down the 6. 3 goes into 6 2 times. 2 times 3 is 6. Subtract, get 0. Bring down the 1. 3 will not go into 1, so I put a 0. Bring down the 2. 3 goes into 12 4 times with a remainder of 0. So 3 goes into 852,612. 284,204. No decimal, no remainder. 3 is a factor of 852,612 because it is a factor of the sum of its digits. Pretty cool stuff. And finally, here's the divisibility rule for 9. If the sum of the digits is divisible by 9, then the number is divisible by 9. So it's the same rule as 3, but you're just dividing by the 9 instead of the 3. So let me do an example. I won't do such a big number this time. 2,440. So this says if you add up all the digits of the number, 4, 5, 6, 6 and 4 is 10. So put an equal sign there. So 2 plus 4 is 6. 6 plus 4 is 10. Plus 1 is 11. Plus 7 equals 18. Okay, so I just made up a number, which is 24,417. Okay. If you divide the sum of its digits, which is 18, and get an integer, 18 divided by 9 is 2, then this whole number is divisible by 9. So 9 times 2 is 18. Subtract, so we're using the division algorithm. 14 minus 8 is 6. Bring down the 4. 9 goes into 64 6 times. Just kidding, 7 times. Okay. So 9 times 7 is 63. Subtract, 4 minus 3 is 1. Bring down the 1, 11. 1 times 9 is 9. 11 minus 9 is 2. Bring down the 7, and 9 will go into 27 3 times evenly. And we get, so 9 is a factor of 24,417 because 24417 adds up to 18, and that is divisible by 9. Okay? So example 1. This example shows how to apply the 2 new divisibility rules we just discussed. Explain why 378 is divisible by 3 and 9. So it's expand. So I'd say 3 plus 7 plus 8 equals 18. 18 divided by 3 equals 6. So since it evenly divided by 3, then it's divisible by 3. 3 plus 7 plus 8 equals 18 again, divided by 9, and that is 2. So to explain this, you would simply say, since the sum of the digits is divisible by 3, it is a factor of 3. It is divisible by 3. Since the sum of 378's digits, 3, 7, and 8, is 18, which is divisible by 9 evenly, then 378 is divisible by 3. And that's your explanation as to it. Now this section I decided not to do. I understand that this lesson is trying to teach them the distributive property, but they found it very confusing, so I'm going to wait and use, I'm going to wait and do the distributive property with variables rather than introducing it here to it, so I'm not going to do the decompose of this here. Okay, so let's go down to E. Is 18. Okay, so they're just explaining that whole problem, so I'm going to move right on to example 2. Is 3,822 divisible by 3 or 9? Why or why not? So I'm going to take the rule and add up its digits. 3 plus 8 is 11, plus 2 is 13, plus 2 is 15. Divided by 3 equals 5. So 3,822 is divisible by 3. It's divisible by 3 because I got an integer. If I take 15 and divide it by 9, I get 1 with remainder of 6, which is R6. Or 6 9s, 2/3, whatever you want to do. So it is divisible by 3, but 3,822 is not divisible by 9. Because 15 is not divisible by 3. Okay? So now the exercise says circle all the numbers that are factors of the given number, complete any necessary work in the space provided. So there's 3's and 9's, so let's do the divisibility rule. 2 plus 8 plus 3 plus 8 equals 8 plus 2 is 10, plus 3 is 13, plus 8 is 21. 21 divided by 3 is 7. 21 divided by 9 doesn't work. It's 2 and 5/9. So it's not divisible by 9, but it is divisible by 3. And do you remember the rule for 4? If not, go back. I'll show you. The divisibility rule for 4, the last 2 digits are divisible by 4. So let's go back to that. So last 2 digits, will 4 go into 38? 6, 7 times 4 is 28, 8 times 4 is 32, 9 times 4 is 36, subtract, 8 minus 6 is 2, uh-oh, we are going to have a leftover, and it's 9.5, so it is not a factor. It is divisible, but we aren't getting an integer, and that's what this lesson is. Okay? So it says circle all the numbers that are factors of the given number. Complete any necessary work in space provided. So here they're calling for factors, but here they're saying is divisible by. This should say is a factor of, to be actually precise. Because if you say 2,038 is divisible by, well, it's divisible by all 3 of them, but you're going to get decimals. So let's just clear that up. And the explanation is what I have just said. I'm not going to write out the rules again. Okay, so now we have 34,515. I want to know if it's divisible by 3 or 9, so I add up the unit, or the unit plus the tens plus the hundreds and so on and so forth. All these values of the digits. 34515, 345, 3 plus 4 is 7, plus 5 is 12, plus 1 is 13. 13 plus 5 is 18. 18 divided by 3 is 6. 18 divided by 9 is 2. So it is divisible by 3. It is divisible by 9. And what are the rules on 5? Divisibility rule for 5. If and only if its units digit, the last digit is 0. So if I come down here again, it ends in 5, so it's also divisible by 5. Okay, or a factor of. All right. Next one. 3, 9, and 2, so I need the rule for 3 and 9 again. 1 plus 0 plus 5 plus 3 plus 4 plus 3 plus 4 plus 1. 1 plus 0 is 1, plus 5 is 6, 9, 13, 16, 20. Divided by 3 equals 7, so it's a factor of 3. 3 is a factor of it. 21 divided by 9, we already know, is 2 point something, so it is not, 9 is not a factor. It ends in 1, which is odd. It is not 0, 2, 4, 6, or 8, so it is also not a factor of 2. It is odd, not even, not divisible. For 4. We're looking for 3s and 9s again, so we're going to do that rule. 4 plus 3 plus 2 plus 0. 4 plus 3 is 7, plus 2 is 9. 9 divided by 3 equals 3. Yes. 9 divided by 9 equals 1. Yes. Ends in a 0. Yes. Okay. And the last one. 6 plus 2 plus 4 plus 0 equals 12. Divided by 3 equals 4. 12 divided by 9 equals 1. Remainder of 3. So it's 1 3/9 or 1 1/3. It is not an integer, so no, yes. And the rule for 8, if you forget, go back. The rule for 8 says that the last 3 digits are divisible by 8. Okay, so the last 3 digits. So I'm going to simply do this. The last 3 digits are 240. 8 times 3 is 24. Subtract it 0, bring it down to 0. 8 will not go to 0, so I just put that, and it is 30. It is not a fraction or a decimal, so 8 is a factor of 6,200. Okay, that's the end of lesson 17. Go do your prompts.